Well, hello everybody, and welcome back to the bench here, where you never know what you're going to see next, huh? So I ordered this about a couple weeks ago or a month ago. It's been a while, and I've been actually looking for one of these for quite some time, and finally settled on this one. And I don't know what it's going to be like. I don't know. We're gonna test it. But what this is a variable DC load. Now, any of you who are into electronics will probably understand what one of these is and why you would want one. An electronic load is something that you can attach a device to, and this will very precisely draw a certain amount of current and so forth, a preset wattage, so that you can very precisely put a load on a device to test it. So for instance, if you have a power supply and you want to see how the power supply performs under a certain load, you can attach this and set it very accurately to, let's say you want to see if the power supply can deliver 3 amps of current at 12 volts. You can actually set this to draw the 3 amps at 12 volts and test out your power supply. Another thing you can use it for is to use it as a load to test a battery. So you can attach a battery and you can test the actual capacity of the battery with this. So there's lots of good uses for a variable DC load. Now, there are all kinds of different ones. A lot of them are in a case. They almost look like a power supply. And there are many different manufacturers, and you can they're relatively expensive, to be honest. Even like a low-end unit can very easily set you back, $700 or $800 US, and some of the really high-end ones can be in the many thousands of dollars. And of course, they're very high quality and very accurate and so forth. But it's a big investment to make, and it's a large item to have on your bench, especially if you're not going to use it a whole lot. The thing that was appealing to me about these is it uses some pretty basic off-the-shelf parts, including a heatsink for a CPU, as you can see. This is something you just see on a CPU in a computer, in a desktop computer. And let's take it out of the box here. And you can see there's not a whole lot to the circuitry. And of course, I don't have a schematic for this, and I'm just opening it. I haven't even taken the wrapping off of it yet. But you can see that it's very, very simple. There are several input jacks for different types of USB connectors. There is a input for the power supply, and it comes with, I think this is the power supply here. We'll open that stuff in a minute. It has a LCD display, backlit, really nice display on it, you can see. And you can see the current shunts right here. So this is pretty impressive. Now, this one, I'll have to look up the specs, and I need to print it out here from the eBay seller. And I will give you the name of the product and everything, but I'm kind of afraid to give you the actual eBay seller because of what happened with the soldering station. That I'll give you that product ID, and all of a sudden the price will shoot up. But this was a very reasonably priced DC load, and a lot of them you can buy them in kit form that have a smaller heatsink or a passive heatsink without a fan. But this one is actually, I think, 180 watt dissipation, and it can draw up to it can provide a load of up to 20 amps, and can withstand voltages upwards of, I think, 200 volts. Of course, not 200 volts at 20 amps, because that would exceed the 180 watts. But it has a very wide range of loads that you can set it to, whereas the little kits that you used to get from eBay that looked similar to this were only about 60 watts, or 1/3 of what this thing can do. So for the price, I thought I would finally take the plunge and purchase one, and if it works out, then I have a really nice DC load that I can use, and I got it for a very reasonable price. So it comes with a piece of paper here, and I'm imagining this would be the instructions. Yep. And you can see, let's see here. I haven't even looked through this, but somewhere it says, yeah, current adjustable range 0 to 20 amps with an accuracy of 50 milliamps. The voltage measure range is from 0 to 200 volts, and it takes a power supply of DC 6 to 12 volts. So again, it's a pretty nice unit, and I believe it will go up to 180 watts. And you can see the trip point, it looks as if is set at 185 watts. So I would imagine this is a maximum 180 watt DC load. So let me read through this and get a little more familiarized with it. Let's look at, and it does come with a cheap little switch mode power supply. So, and that is 9 volts at 1 amp. And it comes with this little test cable, which I'm not sure. So these are supposed to, I guess, go into here and just be a set of clips. And then this one goes into the USB socket. I guess this is so that you can test USB devices. I don't know. And I believe that all these jacks are here so that you can plug different USB devices in here for 5 volts and actually measure the current draw on them. And you can also plug in the rechargeable USB battery packs that you see so often and measure the charge and discharge rates of them. So this might be pretty cool. So let me get it hooked up, let me test it out, read the instructions a little bit, and we'll do a demonstration and see what we think about it. I've had a little bit of time to spend with this thing and work on it and figure it out, and actually I'm pretty impressed with the way it works. So as you can, if you look here, I have just a couple of wires connected up, and let's just do a quick rundown on what everything is. First of all of these jacks here, different types, are actually inputs. So all the different types of USB inputs for checking batteries or whatever, for to put a load on them, that's what these are all for. And then the main terminals would be these two up here. And again, this thing can actually create a load that will draw up to 20 amps. Anything above 20 amps, it'll cut out. And that's the other thing, is this does have adjustable settings for maximum trip points, for the voltage, for the wattage, and for the current. So to adjust that, what you're going to do is you're going to hold the power button down, plug it in, and you can see it comes up in A, and there's volts, and you can go through this and you can change these settings. So if you hold the button down, then that lets you scroll through, and for instance right now we're in amps, and what this would let you do is, by adjusting this number, you can set a trip point for the maximum amount of amps that this will permit, and anything above that it will limit. So you can set voltage limits, amperage limits, and wattage limits. Now if you unplug it and just let it shut down, and then you plug it back in, that powers it up in normal mode. And by pushing the button slowly, one time, one push at a time, it will let you scroll all the way through to the different settings. So it comes up like this by default, which is all Chinese writing. If you click it one time, it'll show all of these in English. And then this is a different display that has large numbers for the voltage and current. Click it again. This is my favorite mode right here. So it has the voltage and current, shows the wattage up here, the amp hour, the watt hour, and most importantly, it will actually calculate the resistance that would appear across these two terminals. So let's hook it up to a power supply and I'll demonstrate. So if we look up here, I have my benchtop power supply. This power supply can deliver up to 5 amps at 30 volts. I just have it set to about 10 volts right now. And if I connect it, you see I'm just going to plug it in like this. I'm going to do that after I get you back down here on the device. And I'm going to connect this up. And it displays the actual voltage. And it's pretty accurate to at least within a tenth of a volt or so. And what I've noticed is it even picks up the drop, the voltage drop in the wire that you're using. This is a relatively thin piece of speaker wire. So there is a little bit of voltage drop in it. So I have 10 volts up there on a power supply, and you can see there's a little bit of drop here. Now, here's the most important thing. On the higher end, more expensive DC electronic loads that are out there, you dial in, you type in, you preset what current you want it to draw. So for instance, you could type in 3 amperes and it will draw 3 amps. This doesn't do that. There is no preset on this. So these knobs, when you connect a power source to it, they have to be all the way counterclockwise. So this is the coarse adjustment and this is the fine adjustment. These are your current knobs. So fine and coarse current. And if these are turned way up, it can actually draw very heavy current and exceed the current limit of what you're trying to test. So it's very important to start out with this thing, and it says right in the instructions to do that. So there is no preset. Now you can once again go into that menu and set a trip point, so it will limit the maximum current that it can do, but really you need to start down here. Now if I start rotating this fine adjust a little bit, it will eventually kick in, and once the current gets up to a certain level, you're going to see there goes the fan, and the fan will kick on. So right now we're at 0.65 or 650 milliamps. So we can rotate this, and it's kind of touchy. Even the fine adjust is touchy. So there's 1 amp, and we have 9.87 volts. And let's adjust this so it says right around 10. And there you go, right around 10. And a really cool thing about it is, of course, R equals E over I, or R equals voltage over amps, or voltage divided by amps. So if I take 10 volts divided by 1 amp, or 1.01 amps, let's say, that should give us about 9.9 ohms. And if you look down here, sure enough, it's right around 9.9 ohms. So this actually works pretty well. And as you can see right here, we're seeing 1.01 amps of current. And if we look up here, 1.01 amps of current. So it's very accurate. So I'm very impressed with how this thing works. Again, it's kind of rudimentary when you compare it to, you know, the $500 or $1,000 one that you buy, this programmable. This is certainly not as per se programmable, but it works. It's a DC electronic load and it works. And I can easily go clear up to the 5 amps that my power supply can deliver. And sure enough, it'll draw 5 amps, 5.02, and right up there, 5.03. Now, what you will see though is we have 10.1 volts at the power supply, and we're actually seeing a bit of a voltage drop, both from the thin wire, you know, the thinness of the wire, and of the power supply starting to sag a little bit because it's rated at a maximum of 5 amps. So right now, it is, if I go a little bit more, did you hear that little click? I'm at 5.1 amps, and as you notice, I'm delivering that, but my voltage went into tank right now. We're down to 670 millivolts, and that's because of the current limiting of the actual power supply itself. When I get down to 5 amps, it goes right back up. So there you have it. So really there's not a whole lot more to this. Each press of the button, this tells you backlight on and backlight off. This tells you that anything above 300 volts it will shut off. This tells you it's set that there's no minimum voltage that's set, so you can have it shut off when it gets below a certain voltage as well. It shows you greater than 100 amps, which I don't think I would ever try to do that here, and 185 watt maximum, and that's the maximum wattage that this DC load can dissipate. And then we scroll back through and back to our little screen. Now, here's where it gets kind of interesting. You can reset the data. So for instance, if you press it 2 times, that clears the capacity data for the amp hour, and you notice that zeroed out. If I click it 3 times fast, that clears this one, the watt hours, and notice it starts counting again. If I click it 4 times, that changes the time. So this is a timer that tells you how many seconds it's drawing that current. If I click it 5 times, that sets the auto standby mode and the timer for the discharge alert. Then if you click it 7 times, that will clear everything and reset it to 0. Now you're supposed to click it 7 times when there is no load, like this. So you can see it shut off because it tripped. So if we do that again, and it reset, now everything's calibrated to 0. Plug it back in, and there we go. So that's how it works. It's, like I said, very basic, but it will do exactly what I want it to do, and that is just be a basic current load, a DC electronic load that is affordable. So I'll try to put a couple of links on the video, but I don't want to give you a direct link to the site that I purchased it from. You'll see if you do the Google search for this, or the eBay search for this, you'll see 100 of these pop up at different sites. And if I just give you one site and everybody goes there, we know what happens. The price will start shooting up. And I forget what I paid for this thing, but it wasn't very much. I'm thinking in the line of $30 or $35 US, something like that. And considering that one of these, if you buy a programmable one like from B&K Precision or one of those companies, or HP or Keysight, you can really get into many hundreds of dollars for something that has a similar rating to this. Of course, it's in a nice case and it's programmable, doesn't use those little pots like that, but still, for what this is, it works great. So I got to give this one a thumbs up, and I would ask you to do the same if you like this video. I know it was kind of just a short, quick one, and as always, I wish you all the best and good health, peace, joy, and happiness in your lives. And until next time, we'll see you, and take care. Remember, give us a thumbs up and subscribe.